In this segment, we're going to continue with geometry, and we're going to be talking about rectangles, squares, parallelograms, basically covering the types of polygons, and we're going to be covering circles. We're going to be talking about the number of degrees in these different figures, and we're going to be talking about the relationship between the different sides on some of the polygons. So let me just add to that with this brief introduction that it's going to be very rare on the SAT for you to see something that's just specifically about a circle, for example, or specifically about a square. What they do to make it a little more complicated and to really challenge your thinking is they're going to combine these different figures. You maybe have a rectangle inside a circle, or a circle inside a rectangle, or a triangle inscribed inside a circle, and it's going to call on all your knowledge. So with that, let's look at some specific characteristics of these different shapes, and then we'll go on to look at some specific problems. Okay, let's take a look now. I talked earlier about some different shapes. Let's look at those shapes and look at some of the different characteristics. We'll start with a circle. And there's several things you need to know about the circle, and you probably already know this, but we'll go over it anyway. Of course, one of the first things you have to remember, the number of degrees that are in a circle, and that's always going to be 360 degrees. The other thing that you're going to have to remember about a circle is that if this is the radius, you have to remember that if you go all the way across, pretend that's a straight line there, that's the diameter, and it's 2 times the radius, because you may have a situation where they tell you the diameter, but the relationship they want you to solve to is maybe about the radius. So you have to remember how to get to the radius if you have the diameter. And I know that's pretty basic, but we'll just go over it here. The other thing is that you will need to know how to use the formula for the area of a circle. Now don't worry about remembering the formula for the area of a circle, although it's pretty easy to remember, because all these formulas for these different geometric shapes are in each of the math sections. They give you that little cheat sheet that I talked about earlier. The area of a circle, of course, is A equals pi r squared. And the other thing is this distance around the circle, which is called the circumference. The formula for that, and that's also given to you in the front there, is 2 pi r. And you can see right now, because both of them contain pi r, that maybe they'll give you the circumference but ask you something about the area, or they give you the area information and ask you about the circumference. So you'll play those two things together sometimes. Let's look at another shape here. This happens to be a rectangle. Not all the sides are equal, but this side is equal to that side's equal to that side, and they're parallel. And one of the things about any polygon is that the sum of the different angles in there is always going to be 360 degrees. And if you think about it, that makes sense. Let's just draw a diagonal here. You basically break that rectangle into 2 triangles. And as you know, a triangle has 180 degrees, so 2 times 180 is going to be 360. So it's easy to remember there's always 360 degrees in a rectangle. It has a formula too, and it's a simple formula. It's just simply the length times the width. And it doesn't matter where you decide whether that's the width or the length, and whichever, because since it's just 2 things multiplied together, you'll come out with the same answer. And we don't talk about the circumference of a rectangle. We call it the perimeter. And the perimeter of a rectangle is going to be equal to 2 times the length added to 2 times the width. Now let's look at its cousin, the square. Now the square, all its sides are equal. Let me pull it down just a little bit further here. All the sides are equal. So you don't have to say length times width. The area is simply going to be whatever that size is, side of one of the sides squared. And the perimeter, of course, is going to be 4 times whatever one of the sides is. The next shape I'm going to show you is, I tried to make this a semicircle. That word semi is important because it means half of a circle. And so the implication here, if it's half a circle, it's only going to have half as many degrees, 180. It's going to have the same radius because this is the center of the circle right here. This thing's a little off in calibration there. If that's the center of the circle, the lines going out to any point is going to be the same radius as if we had the full circle. And finally, let's look at one more polygon. This is the parallelogram. And all these have parallel sides, but the thing that you're often going to see is that they'll, with parallel lines, if there's a line that's passing through them, these angular relationships you're going to have, like the alternate interior angles of a transversal crossing parallel lines, they're going to combine these concepts. And as I mentioned in the introduction, it'll be rare to just have a circle problem. They may inscribe a circle inside a rectangle, or they may put a rectangle inside a circle, or even put a triangle inside a circle. Maybe you'll see something like that. I think specifically I'm going to be discussing one of the problems that's a practice exam problem that does that. So let's look at some of those specific examples now. Okay, let's start out here. We have a simple rectangle. And just like when I was talking about the rectangles earlier, you've got side x's here that are equal, and you've got side y's that are equal. And they're not all equal, or it would be a square. And in this problem, it's problem number 16, so it's perceived as being difficult. However, I think you'll agree when you see how this is solved, it's not all that difficult. If the perimeter of the rectangle, A, B, C, D, is equal to P, and X equals 2/3 of Y, what is the value of Y in terms of P? Y in terms of P. That means you want Y on one side of the equation and P on the other side. And if you look at your 5 possible answers here, they're all in relationship to P. So how do we do this? Well, we start with this right here, perimeter. As I mentioned earlier, perimeter is equal to 2 times the length plus 2 times the width. Now in this case, it's going to be X and Y and not L and W. And so the perimeter is going to be, let's write this on this side since we want P on the right side. Let's write this as 2x plus 2y equals P. Now, to compare apples with apples, I've got this convenient piece of information here. It says x equals 2/3 y, so that's going to make our addition pretty easy here. We're just going to substitute, and we end up with 2 times 2/3 y plus 2y equals P. And when we multiply 2 times 2, of course, we get 4/3 y. And I could just go ahead and put 2y here, but I'm going to make it easier for me. I want it in thirds since this is thirds over here. So I'm just going to make 2 6/3 instead of just writing it 2, because 3 goes into 6 2 times, and make that y. And now I can add these 2 fractions together. 4 plus 6 is going to be 10/3 y equals P. I'll put this P over 1. Now, we want y on one side and we want p on the other side. This is where you can cross multiply here. We can take 1 times 10y, I'll just write it over here, 10y, and we're going to say that equals 3 times p. Now we have y on one side, p on the other, but I got to get rid of this 10 over here. What you do to one side, of course, you got to do the other. We're going to divide by 10 on both sides. These 10s will go away, and we're going to have y equals 3p over 10. Now look at your answers down through here, and you'll see that B is our correct solution. Okay, here we have a problem, and you're probably going to see quite a few of these, or at least one of these on an SAT. And it's where they've got several of the shapes and they're in proportion to each other in some manner. In this case, it says in the figure above, the perimeter of the square A is 2/3 the perimeter of square B, and the perimeter of square B is 2/3 the perimeter of square C. Now, if the area of square A is 16, right here, what's the area of this bigger one way down here on the end? Now, they've given this a 3, so it's supposed to be simple. And hopefully you'll think it's simple when we take a look at it here. Okay, we know they're squares, so we know all the sides are equal. And they've already told us that the area of this square right here, A, is 16. And when we were looking at the things earlier, we said that the area of a square is equal to s squared. And so what is each of the sides of that square? Well, it's 16 equals s squared. Then the square root of 16 is going to be what the side is, and go ahead and draw those square root signs. And that means each side's going to be 4. This is going to be 4, this is going to be 4, 4, 4. Now, to get the perimeter, because we want to get things in terms of p here, we just add all the sides together. And 4 plus 4 plus 4 plus 4 is going to be 16. So we know p equals 16 here. Now, we also know that the perimeter of B is 2/3 bigger than 16. So turning this around, because we're looking at it going this way, that would be 3/2 times 16. We have to flip it. So that would be 16 times 3/2 would give us the perimeter B. 3 times 16 is going to be 48/2, and that equals 24. So we put P equals 24 here. And then C, again, it's going to be 3/2 times this 24. So we take 24 times 3/2, and 3 times 4 is 12, carry 1, 72 divided by 2, and that's going to be 36. So we know this one is going to be P equals 36. And now they want to know, what is the area of C? Well, we've got 4 equal sides, and we've got 36 total. So 4 goes into 36. We know each of these sides has to be 9, okay? And to find the area of a square, you just take one side times the other side, since they're all equal. 9 times 9 equals 81, and that's this one down here.